Yes, welcome once again to the class. Let's start. So we had already learned in the previous class that when resistive force was proportional to velocity, what was the situation? But that situation we had derived the displacement as well as velocity expressions. But in reality, those expressions were not valid for particle under gravity. So now we are going to derive the expressions for a particle falling under gravity. Okay, and particle, although it is falling under gravity, you have in the 11th and the 12th standard, what did you do in the 11th and 12th? Actually, you used the equation of kinematics, like v equal to u plus at, h is equal to ut plus half at square, v square minus u square equal to 2as, right? You used all these equations of kinematics and substituted in the place of a the value of acceleration due to gravity of earth, right? But you had neglected one thing over there in 11th and 12th. What did you neglect? You neglected the air resistance, okay, which is faced by the falling object. If you if you drop an object from a certain height, if you drop an object from a certain height on moon, suppose, so on moon the equation of kinematics can be easily applied. If you drop a ball from a lower height, if you drop a ball from a lower height on moon, then what will happen? The Suppose you drop a ball from a height of suppose 50 meters from the on the moon, okay, and you will be surprised to know that on the earth we if we jump from the second floor, right, on the earth, if we jump from the second floor of the building or first floor, even first floor of the building, you will be surprised to know this, that if we jump from the first floor of earth's building, suppose there is a building on earth and we are standing on the first floor and we jump from there, then we will obviously our legs and hands will be destroyed, we will become physically handicapped, okay. But you will be surprised to know that on moon, even if you jump from the third floor, suppose there is the same building is on moon, suppose the building which you have on earth, suppose the same building you have on moon, suppose, then what happens? Even if you jump from the fourth floor, even if you jump from the third or fourth floor, still neither will your hands be broken nor your legs be broken. You can actually easily land on the earth, sorry, on the moon, okay. Your legs and hands will be all right even if you fall from third floor on the moon. So that was an interesting fact, okay. Now, what is the reason behind this? The reason is very simple. The acceleration due to gravity on moon is very less as compared to earth. This is the main reason. And another reason which is there, which is also on account of acceleration due to gravity only, that is your weight reduces on moon, your mass remains same, okay. Whatever mass you had on earth, the same mass you will have on the moon also. Mass will remain same, but weight will change on moon, because the value of g, that is acceleration due to gravity, that is not 9.8 on moon. On earth the acceleration due to gravity is 9.8 meter per second square, but on moon the value is far much less, okay. I think around something 2 point something is the value, if I am not wrong, okay. On moon the acceleration due to gravity value is 2 point something. Now why I am making you imagine moon, okay, I am making you imagine moon because there is a reason behind it. Suppose you throw a ball from a certain height on moon, then what will happen? The ball will fall down as you have dropped the ball from a certain height. you must be knowing that moon does not have any atmosphere. Okay, so as moon does not have any atmosphere, the ball which you drop from a certain height on moon, that will strictly follow, that ball will strictly follow the equations of kinematics, like s is equal to ut plus half at square, v square minus u square equal to 2as, v equal to u plus at. These equations will be strictly followed on moon because moon has no atmosphere. In the place of acceleration, you will put the acceleration due to gravity value of the moon, and you can easily calculate. And these equations are very accurate on moon. Why they are very accurate on moon? Because moon does not have any atmosphere, and as moon does not have any atmosphere, it has no air resistance. Moon has no, even if you drop a ball on moon, the ball faces no air resistance because there is no atmosphere at all. Okay, but on earth there is air resistance. And when you had solved the equations of projectile and kinematics in your 11th and 12th standard JEE time, remember, do you remember, in the at the time of JEE or NEET, whatever might be your field? Okay, but most of you might be from the JEE side because NEET people usually drop physics. Okay, NEET people usually go for zoology optional. Okay, NEET people, those who aimed for AIMS in the 11th and 12th, those people take either botany as an optional or zoology as an optional subject in UPSC. Okay, those people don't take usually physics. Usually physics taking people are usually engineering people. Okay, most of them, and some BSc people also, obviously. Now, in the at the time of JEE or NEET, there was a subject physics to you which you had to learn, and in that subject you have learnt that the equation of kinematics hold good on earth. You have learned that, but no teacher gave a stress, on the fact that air resistance is also existing on earth. Okay, if suppose earth did not have any atmosphere, then what will happen? If suppose earth did not have any atmosphere, then the equation of kinematics will hold good on earth, so like just like moon, if earth had no atmosphere. But as the earth has atmosphere, so there is a air drag, the air opposes the motion of the ball. Okay, so such is the situation. You will be surprised to know that on the moon, do you have you ever seen a feather of a bird? Feather of a bird. Feather of a bird means pank, pakshi ka pank. Have you seen it? Feather of a bird. So if you have ever seen the feather of a bird, you will realize that it does not follow the equation of kinematics. Why it does not follow v square minus u square equal to 2as, v equal to u plus at, s equal to ut plus half at square? Why the falling feather does not follow these equations? Because the air resistance becomes the dominating factor on earth. In case of a feather of a bird falling on the surface of the earth, the equation of kinematics are not the dominating factor because the feather is very light, and as it is very lightweight, air resistance is able to act on it, and air resistance actually dominates, okay, instead of equation of kinematics. So such is the situation. But if you take the same feather of the bird on a moon, suppose, and you drop the feather of the bird on the surface of the moon, then the feather of the bird will fall in a straight line. You will be surprised to know that on moon, feather of a bird, if you take and you drop it from your hand, so you will find that the feather of the bird is falling in a straight line, just like a ball. The way a ball falls on earth, the same way the feather of the bird will also fall on moon. Why? Because there is no air resistance. As there is no air resistance, the feather of the bird will face no opposition from any factor, because there being no atmosphere on the moon. So as there is no atmosphere on the moon, the feather of the bird will also fall in a straight line, and on the earth never such situation can arise because earth has an atmosphere. So such is the situation. Okay. Now in case of a heavy object, if you consider a very heavy object and its surface area is very low, suppose you have a ball has a very low surface area. Okay. So in the equation of kinematics which you used in the 11th and 12th standard, you had actually ignored the air resistance while the ball was falling. So you had taken a idealistic situation. Why you had taken such a situation? Because taking air resistance into account complicates the situation a little bit. Okay. And as it complicates the situation a little bit, a person of the age of 14 or 15 years might not be able to deal with such complexities. So as the person of such a young age can't deal with such complexities, so that's why the very easiest path that JEE or NEET students follow is that, and the paper setters also follow the same path, that they ignore the air resistance. Okay. Now in the case of IAS physics optional, you will have to take into consideration the very air resistance which you had ignored during the time of your 11th and 12th, and that's what is our topic today. Okay. So that's what is our topic today. So we will start our topic, okay, in the next class. Okay, we will start our topic in the next class. Hope you have got everything. So we will start from here: particle falling under gravity with frictional force of air directly proportional to V, and all these things. Now this is also just an assumption. Okay, the frictional force is following a perfect directly proportional to V law. Okay, all these are also assumptions. In reality on Earth has an atmosphere, that is true. But is it true that there is no wind blowing on the Earth? Suppose a ball is falling on Earth. Suppose a ball is falling on Earth. This is your ball, and this ball, suppose it is falling on the Earth. Then do you think such a kind of resistive force is possible? In real life I am saying, in physics problem it is possible, but do you think such type of resistive force is possible in real life? In physics problem it is possible, no doubt, but in real life the resistive force directly proportional to velocity, such kind of situation can never arise. Why? Because this is a strict rule, strict mathematical rule. Okay, and air will not follow it. Why will air follow it? Because sometimes the air will blow from here to here. Okay, sometimes the air will, while the ball was falling, the air started to blow from it was blowing initially from here. Now when the ball reached here, the air started to blow from here. The wind changed its direction. Changed its direction. So what will happen? As the wind changed its direction, so the the air resistance acting on the ball has changed now. The air resistance acting on the ball has completely changed now, and as the air resistance acting on the ball has now completely changed, so do you think such type of situations can arise in real life? F is directly proportional to V, or F is directly proportional to V square, F is directly proportional to V cube. No, such type of strict laws cannot be followed by air. Such type of strict laws cannot be followed by air, because air, it can blow anywhere it wants. Okay, according to the geographical feature of a particular place. So air does not follow a rule. So we are taking a idealistic kind of situation, an idealistic kind of air resistance which is following a certain rule. This is what? This is an idealistic kind of situation. Idealistic imaginary situation. Okay, idealistic imaginary situation means, idealistic imaginary situation just implies that we are actually making a prototype. Okay, prototype means if the air would have behaved like this, then what would have happened? Okay, if suppose the air would have acted, or suppose the air would have behaved in this manner, then what would have happened? Okay, so we are basically making a model Okay, we are making a model which is not a reality. Okay, and if in physics it is given that air resistance is there, but suppose there is no law given to you how the air resistance is varying with velocity. Suppose it is given that consider air resistance. Okay, consider air resistance is given in the question, suppose, and it is said that the air resistance is random, just like in real life situations. The air resistance acts randomly, just like real life situations. If such a question is given, do you think such question can be solved? The answer is no. Physics cannot solve such question. Mathematics and on paper you cannot solve such question. Such question will have to be solved with the help of experiment. Okay, it cannot be solved on paper. Such a question in which the air resistance is varying randomly with velocity, there is no rule governing the air resistance. In that case means the real life situations, most of the real life situations, you will have to do the experiment. And after doing the experiment, you will actually, while doing the experiment, you will actually see that how the geography of the area is, in which directions do the winds flow. So you will require one physicist and one geologist also. Both of them will together, uh, not geologist, geographer, physicist also and a geographer also, and both of them will together make this experiment successful. But such situations cannot be solved on paper, so such situations are not given to you. Okay, because such situations cannot be solved on paper. So particle falling under gravity with frictional force of air directly proportional to V. Okay, frictional force of air directly proportional to V, and particle is falling under gravity. So we will learn about this, the mathematical formulations. So I have made you visualize today. Today what I have done, I have made you visualize the situation. Now tomorrow I will just I will just explain the mathematical part of it tomorrow. Okay, so thank you very much.